In this problem, we're given a triangle with a right angle in the corner, and we are asked to calculate the length of the hypotenuse, which is this side right here, the diagonal that's across from the right angle. The other two side lengths are given as root 16 plus root 10 and root 16 minus root 10. So in order to solve a right-angled triangle, you can find the missing side using the Pythagorean theorem, which is that a squared plus b squared equals c squared. And this formula works as long as you always put in for c the hypotenuse. And then a and b are the legs, and it doesn't matter which of these is a and which of these is b, but they have to be put in the a and b spots. So we're going to plug this expression in for a as the root 16 plus root 10, and then that's squared. For b, we'll plug in the other one, which is root 16 minus root 10, and then that is equal to the hypotenuse squared, which is labeled x, so x squared. Oh, and don't forget to put a squared on this one as well. Now, to solve this, I would square out both of these binomials. If you know the pattern for the square of a binomial, you can use that as a shortcut. But if you want to do it in a more kind of guaranteed to get it right way, you could also do it by writing out each of the binomials twice, like this. So root 16 plus root 10 times root 16 plus root 10 would represent the expression of root 16 plus root 10 squared, like that. And then you can add to that the square of the other one, which would just write it twice side by side. Root 16 minus root 10 times root 16 minus root 10. And then that all equals to x squared. So this is the more cautious way to square a binomial. That works pretty well for most people. Now I'm going to use FOIL to multiply this all out. So first times first, root 16 times root 16 is actually just 16. Okay, so that's that product right there. You could write it as the square root of whatever that big number is, 16 times 16. I think it's 256. But then when you square root that number, you just get 16. So you can use this as a property that if the square root of the numbers are the same in both of them, then you just get the number for the answer. Alright, for the outside product, it would be plus the square root of 160, and the inside would be the same thing. And then last times last would be root 10 times root 10, so that's just 10 by our property. Let's multiply out the next group. It's going to be similarly 16 minus root 160 minus root 160 plus 10. And then that equals x squared. The nice thing about this problem is that a lot of the terms are going to cancel out. So since we have plus root 160 plus root 160 here, and then minus here, we don't even have to worry about those radicals. So then that just leaves us with whole numbers on the left, 16 plus 16 plus 10 plus 10. What would that be? Would be 52. Yes. And then on the right we have just x squared. So that cleans up really nice. The last thing is to use the square root property. It says that you can take the square root of both sides to get x, as long as you put a plus or minus on the number side. So that would mean that x equals plus or minus the square root of 52. Now, since this is an actual length of the hypotenuse of a triangle, up here you have to only take the positive solution. So the answer is that the length of that hypotenuse is the square root of 52. However, it's asking us to simplify that, and since 52 factors into 4 times 13, that would mean that that 4 can come out of the square root as a 2, and so it would be 2 square root 13. And in this case, they gave us that the lengths were in inches, so you want to make sure that you include that in your answer as well. Have a nice day.
Made with Doodlecast Pro.